Hello, good morning students. We have learned the rules for block diagram reduction. So today I thought I will explain you how to solve a problem because problem solving skills are required and one of the outcome of this module is or this particular part is you learn problem solving skill. So I thought I will ask you to do the problem, then I thought I will explain one example very slowly and in great detail. So I'll be very slow. So I want you to do other problems. I'll give you some set of problems. I want each group to do one problem. Okay. So that is the idea. So let us go. Let us go forward. Okay. So find the overall transfer function. So this is the question. Okay. So there are G1, G2, G3 is there. There is a loop is there. So how will I go about this? So you should look whether there are any cascade block. Are there any cascade block which we can simplify? G1, G2, G3 are not, we cannot simplify G1, G2, G3 as a cascade block. Why? Because there is a branching point here and there is a summing point here. Because of this, we cannot take it as a cascade block. Are there any parallel paths? No, there are no parallel paths as such, because we know that from the last class that if there are cascade blocks, we could simplify it as G1, G2, G3. If there are parallel paths, you remember it could be simplified as G1 plus G2. So there are no parallel paths also. Now look, are there any closed loops? You see here, there is a closed loop. This is a usual mistake some students may make, but the issue is there is a branching point here. So I cannot take this as a closed loop, because if I simplify this entire loop, what happens? I won't be able to get the branching point. So what should I do? Can I shift any branching point? Yes, I can shift the branching point. If I shift BP2 before G3, because you see the signal coming out of G3 will be a signal which is multiplied by G3. So if I shift this, branching point to the left of G3, then we will get a loop. Is it okay? So this is a key point. So each problem you should look, are there any cascade block? Are there any parallel paths? Are there any closed loops? So in this order, if any of these three is there, the problem is simple. Otherwise, we may have to shift a branching point or shift a summing point, which is sometimes could be messy. So that is how you should solve the problem. So let us go to the next slide. Here I have copied the earlier figure here, since I have made a lot of drawings there. Here see this branching point BP2. What did we decide? We decided that we will shift the branching point. We'll shift the branching point left of, we decided that we will shift the branching point to the left of G3. So when we know the rule, when you are shifting the branching point ahead of a block, you multiply the signal by G3. So this loop, if I am taking from here, it was H1, and you know that the signal here is G3 H1, isn't it? So instead of taking it from here, I'll take it from here. So what is the signal coming over here? It will be multiplied by H1 G3. So this is a crucial step. Okay, when I'm shifting the branching point, I'm shifting the branching point ahead of G3. Then the initial feedback loop was H1. Now instead of H1, it became H1 G3. So let us pause for a while. What should be my next step? What should be my next step? Are there any cascade blocks? No. Are there any parallel paths? No. Are there any loops? So what is a loop? You should be very clear about loop. Loop means a path which starts from like this. So this is a loop. This is a closed loop. So I can simplify this closed loop. So once I simplify this closed loop, so let us plan the how we are going to solve this problem. First I will simplify this closed loop. Then I will simplify this outer loop. Then we are having two blocks in cascade and the problem is done. So let us, as I promised you, we'll do this slowly. Let us go to the next slide. So the same as what we did earlier. So there is this loop. There is this loop is there. What is the overall transfer function of a closed loop? We have learned that rule. It is G by 1 plus GSHS. So here G is G3, H is some H1 G3. So I'll find the overall transfer function of this loop. We'll get the next block. So what is this? So this yellow has been simplified and we got this. What is it? G2 divided by 1 plus G2 H1 G3. Now again look at the diagram. Ask the question: are there any cascade blocks? Are there any loops? So if there are cascade block, simplify the cascade block. Let us simplify. There are cascade block. These two blocks are in. These two blocks are in cascade. So I can simplify these two blocks. So what will be that? It will be G1 G2 divided by 1 plus G2 H1 G3. So I have written it as A to make the figure look neat. So what is A? A is G1 G2 divided by 1 plus G2 H1 G3. So this is A. Now what should I do now? Are there any cascade blocks? No. Are there any loops? Yes. So this is a loop. This is a loop. And what is the transfer function of this loop? That will be A into A by 1 plus A H2. A by 1 plus A H2. So I will simplify this blue and get this blue here. Okay. A by 1 plus A H2. We are done almost. So now we are having two blocks in cascade. One transfer function of one block is A by 1 plus AH2. The transfer function of other block is G3. So the resultant overall transfer function we can replace it by A. So look here. We have from the last diagram we have one block with the transfer function A by 1 plus AH2. We have transfer function A by 1 plus AH2. A by 1 plus AH2 and another transfer function G3. This is a cascade block and you recall that A is G1 G2 divided by 1 plus G2 H1 G3. Now we have two blocks in cascade. So what is this? A by 1 plus AH2 and G3. There will be A into G3 divided by 1 plus AH2. This block is A into 1 plus AH3. So I'm making a mess here. So let me choose one simple color. So this is the first block, A into 1 plus AH2, that into G3 is the overall transfer. The remaining is algebra, you do it and you will get the final answer as G1, G2, G3 divided by 1 plus G2, G3, H1 plus G1, G2, H2. So I hope it's clear. So good luck, solve all the problems, other problems. Each group can solve one problem. Maybe prepare a video like this and share it with others. So thank you very much. That's it.